Java is a multi-threaded programming language, which means we can develop multi-threaded programs using Java. A program can be divided into a number of small processes. Each small process can be addressed as a single thread or lightweight but sub-process. Multi-threaded programs contain two or more threads that can run concurrently. This means that a single program can perform two or more tasks simultaneously. For example, one thread is reading data from file at the same time another thread is performing some computation. Multiprocessing and multithreading both are used to achieve multitasking, but we use multithreading than multiprocessing because threads share a common memory area. They don't allocate separate memory area, which saves memory, and context switching between the threads takes less time than process. Java multithreading is mostly used in games, animation, etc. Advantages of Java multithreading: it does not block the user because threads are independent and you can perform multiple operations at same time. You can perform many operations together, so it saves time. Threads are independent, so it does not affect other threads if exceptions occur in a single thread. Thread. A thread is a lightweight sub-process, a smallest unit of processing. It is a separate path of execution. Threads are independent if there occurs exceptions in one thread. It does not affect other threads. It shares a common memory area. Lifecycle of a thread. A thread goes through various stages in its life cycle. For example, a thread is born, started, runs and then dies. Falling at the stage of the life cycle. New. The thread is in new stage. If you create an instance of thread class but before the invocation of start function method. Runnable. The thread is in runnable stage after invocation of start function method, but the thread scheduler has not selected it to be the running thread. Running. The thread is in running stage if the thread scheduler has selected it. Non-runnable blocked. This is the stage when the thread is still alive but is currently not eligible to run. Terminated. A thread is in terminated or dead state when its run function method exits. Thread priorities. Every Java thread has a priority that helps the operating system determine the order in which threads are scheduled. Java thread priorities are in the range between mean priority, a constant of 1, and max priority, a constant of 10. By default, every thread is given priority, normal priority, a constant of 5. Threads with higher priority are more important to a program and should be allocated processor time before lower priority threads. However, thread priorities cannot guarantee the order in which threads execute and are very much platform dependent. Creating threads. There are two ways to create a thread: by extending thread class, by implementing runnable interface. Thread class. We can create a thread by creating a new class that extends thread class. Example, class multi-extends threads, public void run function, system.out.println, thread is running, public static void main, string arguments, multi-thread 1 equal to new multifunction, thread 1 dot start function, output, thread is running. A runnable interface. If your class is intended to be executed as a thread, then you can achieve this by implementing a runnable interface. Example, class multi implements runnable function, public void run function, system.out.println, thread is running, public static void main, string arguments, multi m1 equal to new multifunction, thread th1 equal to new thread m1 function, th1 dot start function. This is the runnable interface example. This output is thread is running. Synchronization. When more than one thread tries to access a shared resources, we need to ensure that resource will be used by only one thread at a time. The process by which this is achieved is called synchronization. The synchronization keyword in Java creates a block of code referred to as critical section. Every Java object with a critical section of a code gets a lock associated with the object. To enter critical section or thread need to obtain the corresponding object's lock. Syntax, synchronized object, then statements to be synchronized. This is the synchronization syntax.